I'm Nazanin Sefabad, and today I will be explaining the electromagnetic spectrum, focusing on its key properties, specific types of radiation such as microwaves and infrared, and even their applications. I will also discuss how different types of electromagnetic waves are used in medical settings and crime scene investigation. So, electromagnetic waves are a type of transverse waves, meaning the oscillations are perpendicular to the direction of travel. Unlike mechanical waves, they do not need a medium, so they can travel through empty spaces, and all electromagnetic waves move at the same speed in a vacuum, which is the speed of light. So they consist of oscillating electric and magnetic fields which are perpendicular to each other. So, the main properties of electromagnetic waves are wavelength, frequency, and energy. Wavelength is the distance between two peaks, while frequency is how many waves pass a point each second. These are linked by this equation. So, where c is the speed of light, as frequency increases, wavelength decreases, and the energy of the wave increases as well. So, this relationship is important when comparing different parts of the spectrum. So, the electromagnetic spectrum is arranged in order of increasing frequency and energy. Radio waves have the lowest energy, as you can see, and gamma rays have the highest energy. Each type of wave has different properties and uses depending on the level of energy that they have got. So, microwaves. Microwaves have a shorter wavelength than radio waves, but longer than infrared. They are commonly used in cooking because they are absorbed by water molecules, and which causing them to vibrate and produce heat. They are also used in satellite communications because they can pass through the Earth's atmosphere effectively. So, infrared radiation is emitted by all objects depending on their temperature. It's commonly used in thermal imaging, for example, in night vision equipment or detecting heat loss in buildings. So, infrared waves could transfer energy as heat, which is why they are used in heaters and remote controls. The key difference between visible and ultraviolet light is their energy and their wavelength. So, visible light can be detected by the human eye, while ultraviolet cannot. UV radiation has a shorter wavelength and higher energy, which means it can cause chemical changes. But visible light, which is generally less harmful. And so, as you can see, these has got lower energy and this one has got higher energy, the ultraviolet one. So, in crime scene investigation, visible light is used for general observation and recording evidence. However, the ultraviolet light is more useful in detecting substances that are not visible on the normal light, such as blood, saliva, or fingerprints. UV light causes certain materials to fluorescence, making hidden evidence easier to identify. So, UV or ultraviolet radiation can be dangerous because its high energy can damage DNA, which may lead to some skin cancer or some type of cancers, and it could also harm the eyes. Infrared radiation, although lower in energy, can still cause harm through prolonged exposure, leading to burns or damage to body tissue due to heating effect, as you can see in the picture here. So, X-rays. X-rays are widely used in medical for imaging the inside of the body. They can pass through the soft tissue but are absorbed by denser materials such as bones, which makes them useful for detecting fractures or other types of breaking bones. They are also used in CT scans to produce detailed internal images. However, because X-ray are high energy radiation, exposure must be controlled to reduce the risk to patients. So, in conclusion, electromagnetic waves have wide range of properties and applications. Understanding their differences allows us to use them effectively in fields such as medicine or some other sciences and some other technological things, while also managing their risks. Thank you for listening.